I am thrilled that we are leading off our 2023 program with a keynote address from Dr. Kimberley R. Dr. R is one of the world's foremost client scientists, and she works at NASA's Jet Propulsion Lab. Now, her credentials are so extensive and impressive that I think it would take me the entire time allotted for the keynote address to read them. So instead, please simply join me in welcoming Dr. R to the stage to give us an update on decoding Arctic tipping points and their global message. Dr. R.
Thanks, Brent. Good morning, everyone. Well, it's really nice to be here with you. I went to Columbia a number of years ago and lived in New York for a little bit, and the city has very much changed since I was here. I was delighted to see that the Billion Oysters Project is also here. They were just in their infancy when I started at Columbia, and they are an excellent organization. So I recommend checking them out outside. It's awesome to have a number of you here in person. Thank you so much for joining us on Tuesday morning, and it's good to open this all up with you. So today I'm going to be talking about Arctic tipping points and a little bit more into what we're thinking about and what we're looking at in this type of science. I've got a number of hats that I wear in my different positions, but Arctic research is a big passion of mine. So to get a little bit into that, I did my PhD looking at glacial pollutants, so the things that we release into the atmosphere that get trapped in glaciers and then end up making their way downstream. Since that time, I worked for the Department of Defense and joined NASA's Jet Propulsion Laboratory. And we've also had the opportunity to be part of the 120 people that Lyda Hill have pioneered and helped us raise the image of women in science to inspire young girls and young boys to follow in suit. As part of this, there are a number of displays across the country, and right now at the Cambridge Science Festival, a number of my compatriots have their statues up. And we were able to do a show on CBS, once again, sharing the message with younger folks about climate change. So my research has taken me all over the world. I've had the opportunity to go to multiple mountain ranges at different altitudes and different places in the world, including the Arctic and the Antarctic. Today we're going to be talking a little bit about the Arctic, because the Arctic has a really important role globally, but it isn't highlighted as much as some of the other things that we're talking about in climate change. So I wanted to both raise awareness and help us think about the Earth as a global connected system. Even the poles, even the very far away places really drive that system. A couple research photos there. Okay. So as you know, the planet is changing. When we think about what's going on at the poles, we think about ice melt, right? That's the one that we're all really comfortable with ice melt both in the glaciers, the ice sheets, and sea ice. But there's also a lot of changes going on in permafrost. Permafrost is soil that's been frozen for 2 years or more, and it's changing the architecture and the landscape of the Arctic when that melts. We're getting a lot more water, unfrozen ice moving through the Arctic, and it's transporting all sorts of interesting and legacy species throughout. So this is the thing that's always very interesting to the news, right? What are the microbes that are in the permafrost that are very old, and how are they moving throughout the system? But there's a lot more going on up there, so that's what we're going to be talking about today. It's not only the microbes, but everything else that's changing. I'm sure you're all very familiar with the greenhouse effect, but just as a quick primer, a quick reminder for all of us, the greenhouse effect is why we have life on this planet. We are able to have protection from the sun while maintaining enough warmth for our species to evolve, warm-blooded species. And what's changing is when we add more greenhouse gases to the atmosphere, then we keep more heat in, and things are shifting. But unlike we originally thought, the climate scientists originally thought, it's not just going to get hotter and drier. As we have all lived through this summer, there's been a ton of changes that include changes in the hydrologic cycle, the water cycle, changes in the vegetation structure, the way the animals function and live, where they live, snow and ice. So there's a lot of different dynamics that are changing. And part of what I'm going to do today is get into why these are changing and what some of the drivers are. Oh, let's see if I can make the, aha. So one of the things about the Arctic is that it's really important for stabilizing the global system. It's important for stabilizing the atmospheric and oceanic system, but it's also changing faster than the rest of the world. We had suspicions about this for a number of years, but then last year, a paper came out in Nature that finally quantified this. So now we know that the Arctic is changing 8 times faster than the rest of the world. The polar magnification is 8 times more. And that's true for both poles, but today we're going to be focusing on the Arctic. And in this graphic, when we're looking at the sea ice, the oldest sea ice that still exists was about 9 years old a couple years ago. Now, the reason that I think that the Arctic may have already crossed some of our tipping points is simply because in order to regrow ice that's that old, and we'll cover it in permafrost as well, but in order to regrow ice that's old, it has to be cold enough to grow ice for 9 years in a row. It's the hottest summer on record. So it's very unlikely that we're going to be able to regrow and maintain old ice year over year, which means that we may be on a downward slope towards sea ice. Now, the same is true in permafrost. As I mentioned, permafrost is soil that is 2 years or more frozen. It also covers 1/3 of the Earth's surface. That's insane. I don't know about you all, but I hadn't really thought about permafrost before I came to NASA. I was very excited about ice, I was very excited about oceans, but I hadn't really thought about permafrost, something that covers 1/3 of the Earth's surface. Big part of that is because of Russia, huge landmass in Siberia. But the take home from this is that permafrost, which is made of years and years and years and years, hundreds of thousands of years of detritus, old organic matter, plants, animals that have died, and it's kind of grown the substrate year over year. It contains the potential for 1,700 gigatons of carbon to be released to the atmosphere. At the bottom of the slide, you can see how much we've released since 1850. A lot more. So a big part of what I want to have the take-home message today is not only is everything connected, but it's really important that we do everything we can to stop climate change so that we can slow down the warming of the Arctic, because this is a huge amount of carbon that could be re-entered into the atmosphere, which will really change the circulation of the planet. Oh, looks like we're having some mic issues. How are we doing? Okay. All right, so let's talk a little bit more permafrost. Permafrost remains all the way from the last ice age and glaciations before that. So it can be up to 1 million years old in some places, hundreds of thousands of years old in some places. And it contains organic carbon, right? Vegetation and animals that have passed away, and also viable microbes. So this is the thing that the news has been very interested in recently, especially because we've got all sorts of really fun new shows coming out about how microbes are going to zombify us all. But these microbes can be as old as the Cenozoic, really, really ancient. And even though we know the ones that release carbon into the atmosphere, methanogenic microbes, there's a lot of other kinds that we're either not familiar with or that we're just learning about. Some of them might be already entrained in our modern environment, but some of them are really novel because they're from an older environment that have been preserved like a time capsule into the future. And now the melting of the permafrost, the thawing of the permafrost, is the ability to release them. One of the things that we're going to remember, and I'm going to keep saying over and over again, is cold temperatures are stable. So the goal would be to preserve the cold temperatures at both poles. So as a point of interest, let's talk a little bit about the microbes. So when we're talking about the microbes that are stuck in the permafrost or that are entrained in the permafrost, we're talking about what we call extremophiles. These are microbes who are able to survive in really high pressure, low temperature environments for a really long time. When you think about something that can live 500,000 years or more in a quiet and reserved state, it's really, really amazing that they have the ability to maintain life that long. We call them Methuselah microbes because they can often come back from the dead and uptake carbon again when they are released into the modern environment. In addition to these ancient microbes, we've also found things like the plague, Black Death, and smallpox, and new viruses including Alaska pox and anthrax. Now, I'm sure you've heard a lot more about this. This is simply because people were buried, victims of these illnesses were buried in the permafrost, because there was a thought that the permafrost was going to stay frozen forever. So humans used it to store a bunch of different components, including this kind of viral infection. Right now, there have been no known transference to any kind of organism, and most microbiologists that I speak with feel pretty comfortable that's going to stay the same, at least for now. One of the interesting things is we've also found bacteria that are resistant to a number of antibiotic suites, even though they evolved and lived before antibiotics were developed. So there's potential strategies for survival that we are still getting a hold of and still understanding, simply because they evolved in a world completely different than ours. They're from an ecosystem that's completely different than ours. And so to get a better understanding of what this looks like, we recently used one of the tools that's on the Mars rover to characterize some of the microbes in the Arctic. Now, it's really cool to just very quickly think about Earth as a proxy for other worlds, even though we have no other worlds that we know are habitable and no way to travel to them, which is why we really want to preserve this one. We do have the ability to think about and look at what's going on in Earth and think about how that could be extrapolated to other atmospheres and other environments. So that's one of the things that we do throughout climate science, is using proxies, because we don't have a good understanding of what the Arctic would look like thawed or melted, and we don't have an understanding of what Mars could be like in person. So we're trying to extrapolate across lots of different fields, and this is one way that we're trying to find microbes in the Arctic. Now, the other thing that I think about a lot is the way that pollutants are moving throughout the Arctic, and it's for the exact same reason as the microbes. Humans have used permafrost to bury and maintain a lot of things that we really didn't want anymore, whether it's oil drilling equipment, old tankers, nuclear bombs, that kind of thing, that are stored in the Arctic, and then now that it's melting, now that it's thawing, have the potential to come out into the larger ecosystem. This is a lot of data, and I'm not expecting you to read it, but I am going to tell you the take home. There is a lot of stuff in the Arctic. Everything from DDT to heavy metals to fallout from nuclear tests to storage of actual nuclear waste. This is all entrained in different parts of the Arctic, and we're not even really sure where. I just got back from a field expedition in July, and part of the goal was simply mapping where we were finding old barrels of oil that had been stored in the permafrost. So once again, another excellent reason for us to work really hard on keeping the Arctic frozen, as we think about all the different things that could come out of the Arctic and re-enter the environment. And this is going to get us into a little bit more of a global perspective. So the question that everyone always asks is, could hazards transport globally? The thing that we need to remember is that the Earth is a closed system, okay? So everything that's released on the Earth stays on the Earth, and it will move throughout the Earth. So the potential introduction of all different types of viruses, bacteria, it's possible, but they have to survive in our modern environment, which we're not really sure if they're going to be able to. However, the remobilization of chemicals and toxins is pretty likely, and we have evidence of that already. So this is a really important thing to think about as we think about preserving the biosphere. How do we keep the old contaminants and the contaminants that we're still making from entering the environment and causing degradation, as there's already stresses coming from the heat effect? But the other thing to remember is that when we think about how could hazards transport globally, things that could hurt humans, we have to think about the way the global system interacts. So we're going to go from microbes and toxins to now the discussion of the larger system, the so what of the Arctic. You're all probably aware of the tipping points literature. Linton et al. Were the first lab to really introduce this. I recommend looking through the literature if you have an opportunity to. Basically, the point of this tipping points literature is that there's numerous tipping points throughout the globe that could trigger other ones. So for example, loss of the Greenland ice sheet, the fresh water that is a little bit warmer in some cases, colder in some cases, but is generally lighter because it's fresh water, could change the circulation of the Atlantic simply because of its reintroduction. It can also raise sea levels. That's something we think a lot about, especially in New York. Even when I was here, the Governor's Office of Sustainability and Planning was thinking a lot about this, and the Office of Emergency Management was thinking about sea level rise. But the way that the Atlantic meridional overturning circulation, the Atlantic currents, impact the Amazon, and then eventually impact the Antarctic ice sheet through the Southern Ocean, all of these things are connected. So when we think about tipping points of the Arctic destabilization, it's really big news to think about microbes and big news to think about DDT and nuclear waste. But what we're actually talking about is potential destabilization of the cryosphere, which drives the atmospheric circulation and ocean circulation on the planet. So I'm not going to explain this whole graphic to you. I had learned this from my comprehensive exams for my PhD, and I still have the hand motions memorized for how I taught it to myself. The take home of this is that there are certain drivers in the atmosphere and ocean system that are in alignment with each other. Since humans have been around, with a couple of separate examples like the Little Ice Age, there has been a balance in the system. So the polar cells on both sides drive the atmospheric circulation and keep things steady in the mid-latitudes. It is the warming of the Arctic and the destabilization of these drivers that causes things like cold flashes in Texas. I don't know about you guys, but some of my favorite TV shows are firefighter shows, and they are talking a lot about all the weird dynamics that are happening in all the different parts of the world. So it's starting to permeate even the most remote parts of the television world, that there's a lot of things changing very, very rapidly. And these drivers are in part coming from the destabilization of the Arctic and Antarctic. So I encourage you to remember, as we're talking about sea level rise, we're talking about the other impacts to humans, especially in the mid-latitudes, right? Because there are people that live in the Arctic. We're also talking about a global destabilization. We're talking about the system really starting to change in ways that we have never before seen in human history. So when we're thinking about what's next for Arctic change, on your right, there's a graphic from the IPCC charting glacier loss, and this doesn't include ice sheet loss, but it does include glacier loss. And then you'll see the permafrost graphic again. The red is bad. So those are the areas that are rapidly thawing. So when we're thinking about Arctic change, we are tracking it as a global community. The IPCC is tracking it as a global community, but it's really important to consider the cryosphere. Not only is our local ecosystem changing, but the cryosphere changing drives the way that the rest of the globe changes. And even in something like an El Nino year, we're thinking about the impacts from the cryosphere and at how it's making El Nino stronger and how it's making storms stronger. Obviously, if something like the Atlantic meridional overturning circulation, the Atlantic ocean currents were to shut down, then that's a very, very different conversation. So to stave off all of those impacts, we really have to start working on keeping things cooler. I think we kind of went pretty quickly through that, and I know it wasn't a lot of good news. I wasn't intending to take questions, but since we have a small group, I'm debating. I think we'll take a couple questions here right at the end. One of the things I wanted to remind us all as we're kind of going into that is that everything is connected. Everything in the global system is connected. And this is just another example of that. The goal of today was to remind you all that we are all driving the same bus. We are all in the same global system. The faraway places are now here. So I know that it used to be very, very far away. Shackleton did some amazing walking across the Antarctic, and there were ships lost in the Arctic, but now it's all here. It's all together. We have to think globally at all times. I know that my mom had a tote bag that said, think globally, act locally. Individual actions are not what we need at this point. We do need to drive system change, but we also have to think about the global. There's a potential emission of carbon, microbes, nutrients, all sorts of different things into the environment that are happening concurrent with any other kind of vegetation and mid-latitudinal changes. And it's weird and interesting and cool that the old is new again. Things that were alive in the Cenozoic have the opportunity now to rejoin our modern environment. And even though it sounds like a really interesting experiment to run, hey, what'll happen when these old microbes come out? I think I would prefer not to run that experiment. I would prefer to increase stability in the cryosphere and to keep the global circulation of both the atmosphere and the ocean much more stable than it has been. So we've got a couple different things going on in my research group. We have an ongoing work with the European Space Agency, thinking about the Arctic together and looking at Arctic tipping points. And then one of the things that we're talking a lot about in my research group and across the agency is combining in situ, so one person doing samples, airborne, mid-altitude, and satellite, so that we have the best understanding of data across scales and the best information to give to modelers. This is from the Arctic Ocean. There's a spot in Prudhoe Bay in July. I've been to the Arctic Ocean in many Scandinavian countries, and it's stunning, unbelievably beautiful, change your life beautiful. And then I went in Prudhoe Bay in Alaska, and you are driven through a giant oil field. There's nothing besides oil, drills, and pads everywhere. You're not allowed to get out because it's all private. And then they take you to a spit that's been made out of old oil barrels. And you can see there in the background a bunch of rusted out oil barrels. And it's just totally different. It's seeping. There's tons and tons of pollution. There's drill sites. There's methane burning off all around. It's not the same Arctic Ocean that you see in Scandinavia. I mean, I guess technically it is the same, but we're definitely treating it different. So this was a feather that I found right there on the spit of the Arctic Ocean. It was a very sobering moment for me, thinking about the impacts that are direct and ongoing from the fossil fuel industry. I read the Heated newsletter this morning, and they were talking about how in the 1980s, the punctuated campaign from some of the fossil fuel folks really started to corrupt the language and the uncertainty around climate change. So let me reassure you, the ongoing climate crisis that we're facing right now is human-made, and we do have the ability to change it, but it's gonna take all of our efforts. And that's why I'm really glad to see you all today. I'm thrilled about the march that happened on Sunday. And again, I do encourage you to check out the Billion Oysters Project. They're super cool. Thanks, everyone. Let's say 2 questions, and I'll say them back since we don't have a mic because I'm doing this impromptu. Yes?
The glaciers, they're melting. You know that. Are the sea levels rising substantially?
Okay.
Will that affect New York and the coastline going all the way down?
The question is, the glaciers are melting, and are sea levels rising substantially, and will that affect New York? Yes, sea levels are starting to rise, or have been rising, I guess, over the last 20 or 30 years. Glaciers drive that a little bit. Ice sheets drive that a lot. There's a bunch of new research coming out about Greenland and how fast it's melting. Antarctica is what we're really thinking a lot about as far as sea level rise, and particularly when it comes to the island of Manhattan. One more question? Okay, have a wonderful couple days and nice to see you all.